Hello once again. If you turn the page, now we're going to look at number 58. And 58 is very similar to the last problem, but this time it gives us a little more context in that s is a position function. Now, if s is a position function, then we know right away that this must be a velocity function. So I'm just going to label this as velocity so that it's easier for us to keep track of this. Now, what is the particle's velocity at t equals 5? So if we follow this graph, the velocity is increasing, right? The velocity is increasing, and then at 5, the velocity would be 2. Okay, at 5, the velocity would be 2. Now, is the acceleration of the particle at t equals 5 positive or negative? Well, remember that s prime gives us velocity, and velocity prime gives us acceleration. So what we're really looking for is s double prime being the slope of velocity. S double prime being the slope of velocity. And if you look right here at 5, I think we can safely say that the slope of that is negative. Okay, so at 5 it would be negative. Now, what is the particle's position at t equals 3? Well, position is an accumulation function. We're starting at 0, and then we are going to 3. So the area under that curve would be 9/2, or you could write it as 4.5. For part D, at what time during the first 9 seconds does s have its largest value? Okay, well, we're accumulating from 0. So the value of this integral from 0 to 6 is going to be positive. Now from 6 to 9, that's going to be negative. So we're going to reach our maximum value this would be at 6. Now, approximately when is the acceleration at 0? Well, the acceleration, remember, is the slope of velocity. So the slope here is 0, and the slope here is 0. So that would be at 4 and at 7. Now, when is the particle moving toward the origin? Okay, well, here it's moving away from the origin. Okay, from 0 to 6, it's moving away. And then the velocity changes, and now it's moving toward the origin. So from 6 to 9, it's moving toward the origin, and it's moving away from the origin from 0 to 6. Okay? Now, on which of the side of the origin does the particle lie at t equals 9? Okay, it's moving away from the origin, then it's moving toward the origin, but it has traveled further here than it is here because of the areas of those regions. So it's on which side of the particle, at which side does it lie? This would be on the positive side. Now, if this area were larger, then it would be the negative side.